Floods have accompanied mankind throughout its entire history. Many cultures have depended on regular flood cycles. In recent years, however, climate change has caused frequent and severe hydrological extremes throughout the world, leading to considerable loss of lives as well as economic damage. As a consequence, research activities aiming at the evaluation and monitoring of the efficiency of different flood systems have been paid increased attention. The Stamfor project is funded by the Ministry of Education, Youth and Sports of the Czech Republic and the joint stock company Vodní zdroje as part of the Eureka program, and aims especially at exploring the possibilities of using sensor technology for the monitoring of flood levee systems. Our company has been engaged in the research on the control and exploitation of groundwater sources since the 1960s. This tradition was further developed in the 1990s and especially after the Czech Republic joined the EU in May 2004. The Stamfor project follows other similar projects that we have already carried out successfully. Resulting from these projects, the GMS, Geophysical Monitoring System method, was developed. This method, which is in common use nowadays, will be used in Stamfor as a basic analytical tool for the design of the installation of sensor systems into the body of the levee and subsequently for their calibration. The geophysical survey will be used for identifying anomalous levee sections showing seepage zones. Based on the survey evaluation, suitable seepage monitoring and, if needed, remediation methods will be chosen. GMS comprises 3 consecutive steps. The first step is a quick test measurement able to provide cost-effective information necessary to assess the structure and homogeneity of the levees on a river basin scale. This measurement is usually carried out using the dipole electromagnetic profiling method. This step is followed by a diagnostic measurement providing detailed information on the structure of both the representative and anomalous embankment sections suggested by the test measurements. For this kind of diagnostic measurement, other geophysical methods, such as the resistivity tomography method, in some cases combined with the spontaneous polarization method, can be used. The third step of the GMS method involves a determination of the geomechanical properties of the levee. The Stamfor project presents a novel approach to levee safety monitoring and assessment. This monitoring is done using different sensor types, such as multi-point sensor probes and distributed optical fiber sensors placed in the body of the levee. Through a mobile network, these monitoring systems transmit collected data to a visualization and early warning system. The entire system can be used by river basin managers or pond owners for remote control of the levees and for failure risk assessment. In 2014, suitable pilot sites were identified both in the Czech Republic and abroad where GMS measurements were performed, and the installation of sensors for further measurements was devised. The pilot site of the Vlčkovický pond in Vlčkovice pod Krkonoší was chosen in order to evaluate how the examined sensor systems reacted to seepage through the body of a dam. The pond dam is highly suitable for the research aim of the project, as there are active seepage zones that enable simulating the increase and decrease in risk phenomena, as well as their impact on the installed sensor technology by varying the water level in the reservoir. After the completion of the geophysical survey by the GMS method, 4 monitoring boreholes were made in the pilot dam in 2015 to provide information on how the water level in the reservoir affected water level fluctuations within the body of the dam. enabling the design and verification of an eventual algorithm in the later stages of the project. After the geotechnical investigation was carried out, a mathematical model of the dam body was made using the geotechnical parameters provided by the survey, and a calculation was done of the flow through the dam body using the finite element method. In this way, a seepage curve was obtained, on the basis of which an optimal distribution pattern of the sensors in the body of the embankment was devised. The design of the optimal distribution was followed by the installation of the sensors themselves. 4 vertical temperature probes, each comprising several single-point temperature sensors placed at different depths, were used in order to cover temperature changes caused by the rising water level within the dam body. In addition to the point temperature sensors, 2 parallel horizontal optical fiber lines were installed on the downstream face of the dam, providing information on temperature variability in the dam body throughout the active seepage zones. The installed sensors were connected to communication modules sending data to the process database of the company Vodní zdroje AS. In 2016, the evaluation of data obtained from the point temperature sensors in the period from September 2015 to March 2016 was started. During this period, the previously emptied Vlčkovický pond was refilled up to its operating level, and thus the seepage zones were activated. Here right behind me you can see temperature graphs on the pilot side of Vlčkovice. What we actually see are temperature variations in time on 2 of the sensors. This spot indicates the point in time and space where one of the sensors was flooded with cold water. A rough model was made that was further processed by statistical analysis methods and converted into an automatic algorithm that continually evaluates the data obtained from the sensors and calculates the status values for each temperature sensor. These values then inform the end user about the risk level for the area where the particular sensor is located. Through SOAP communication protocol, the process database was made accessible to the Korean project partner, the company Aegis, who, as part of the project, created a visualization platform for data imaging connected to an early warning system. In case of increased risk, this system informs the end users of the risk situation by an SMS. In 2016, the data collected by means of the optical fiber lines were evaluated. The data visualization using heat maps showed a highly significant impact of the seepage on the time temperature curve at the monitoring profile, as compared with a reference profile. Given the sensitivity of the optical fiber measurement system, a follow-up research will be conducted by Vodní zdroje AS on the automation of the evaluated data collected by optical fiber sensor systems. Within the Stamfor research project, a monitoring system application has been developed able to detect seepage at its initial stage. This system can be efficiently used to reduce risk originating from failures of earth dams and embankment structures, as it enables real-time monitoring of levees, dams of accumulation, and settling ponds, railway embankments, as well as other critical infrastructures. Our present goal is to turn the Stamfor technology into one of the common tools of dam safety supervision, both in the Czech Republic and abroad.